Hello everyone and welcome back to another video. This video is going to be a journal entry that I wrote in relation to the concept of infinity as described by Pat Corvini in her second lecture of Achilles, the Tortoise, and the Objectivity of Mathematics, her three-part lecture series or course that I bought from the Ayn Rand Institute the other day. And this is a really, really good course. It really does a good job of answering Zeno's paradox and summarizing mathematical concepts such as infinity and distance and all those sort of things. The value that I got out of this course for mental clarity when thinking about concepts like infinity and mathematics is worth far more than the $7 that I paid for this course. And in this video, my main goal is to sort of reflect on those points and summarize them, give a very essentialized summary. Now, this video is not going to be fully in depth and justify all these points in as deep of a way as I want to, but it's going to essentially identify the essentials of what her lecture was about and what her concept of infinity actually means. There may be some lingering questions in your mind after this. There may be some things that go over your head because to develop this point, it takes her a lot longer than however long this video is going to be. I'm sure this video might be like 10 to 20 minutes because I'm just going to be reading an essay out of my journal. But she spends hours trying to develop this concept, connecting it to certain things, and that's not what I'm trying to do in this video. My goal is to simply present that theory in its most essentialized sort of form. That was my goal with writing this entry. It was to summarize what I learned from that, and I figured that you guys could get some value out of hearing a sort of good definition of this concept. In the future, I plan on going way more in depth with this lecture series and discussing essentially everything that she talks about in it. I want to sort of give it a good summary of that lecture series and apply some of my own thoughts going into it and sort of things thinking about how to best explain that to you guys and presenting it to you guys. But that's not what this video is for. This video is more to give a taste of what is to come in the future, I guess. So some Monday, a couple of weeks from now, you guys are going to see in a video titled Resolving Zeno's Paradox and something like that, something mentioning Zeno's Paradox, and that is going to be the full-length video of this, where I go fully in depth explaining these concepts and give a proper justification of these things. However, this video is more to essentialize. So now that we're 3 minutes in with the introduction, let's get started with the actual essay. So let us begin. Infinite is an adjective that refers to a sequence produced by a limited process. Like all concepts, the concept of infinity is abstracted away from individual concrete sequences that are limited in some fashion. To illustrate this, think about Zeno's paradox of Achilles and the Tortoise. Every time Achilles and the Tortoise are in a race, the Tortoise gets a head start. Every time Achilles reaches the point where the Tortoise has already moved a tiny bit forward. So imagine they're racing. Achilles starts. He catches up, but by the time he catches up, the Tortoise has already moved a little bit more. And this process essentially continues. The Tortoise has already moved a tiny bit further ahead. Each time the Tortoise moves ahead, it has less time to do so, and as a consequence travels less distance. Eventually, the distance becomes so small that the measurement tool, used to find the distance between the location of Achilles and the location of the Tortoise, cannot distinguish the difference. Consequently, the process ends as Achilles has caught up. A limit to the distinguishability of the distance between Achilles and the Tortoise must exist for any tool of measurement that we use. There is no point where we cannot divide the distance any further. There's no such thing as infinite resolution. Now, you may be concerned that with this explanation, I'm conflating metaphysics and epistemology here. When I was listening to the lecture, I had the exact same concern. However, you have to keep in mind that division is something that we do for the purpose of measurement. If you have this concern, pause the video or rewind with this principle in mind. Now, let's generalize this sequence of distances. In general form, we arrive at a sequence of terms where each term is defined by the application of a defined process to the previous term. So basically, the sequence of terms would just be the distance between Achilles and the tortoise in each time. And each time that this process is done, it applies the same process to the distance. So like, it's Achilles moves this far, and in that time the tortoise moves this little bit further, and then it keeps going. And this is a defined process. We eventually reach the point where one term is indistinguishable from the last by our method of measurement. So there becomes a point where you cannot tell the difference between where Achilles is and where the tortoise is by your tool of measurement that you're using in that specific process. And every single process, there is some limit to that measurement. At this point, the process ends. In the concept of this sequence, we are omitting when we form a concept of what this sequence is, we are omitting the specific measurements of the limit of our measurement method. So, essentially, when we form that concept, we're saying that we're omitting basically what is that specific limit of measurement. So let's say, for example, we're on a sand track and we're placing pins in the grain of in the sand, and there eventually becomes a point where we have to choose whether to place it on each individual side of the sand, or place them both on a single grain of sand, or place them both on the same side of that grain of sand. And that's the point where they would be equal, essentially, by our methods of measurement. Now we can have a different method of measurement, like a super high resolution photograph, and eventually we'll reach a point where the pixel of the tortoise, of the tiny claw in the tortoise's hand, is indistinguishable from the pixel of the front of Achilles' toenail. And that's when we say they caught up. And we have to reach that for every point because these measurements get closer and closer and closer and closer together. So now, when we form the concept of this sequence, though, we are omitting that specific measurement. We're omitting the measurement of how much resolution our method of measurement has. So we're omitting a measurement of a measurement here. And that's an important concept here. However, we're retaining the characteristic that the measurement must have some limit. No matter what kind of process you're doing, no matter what kind of measurement method you're using, it will have some limit. This is an important concept as well, as in Ayn Rand's theory of concepts, you can think of the fact that every single, you omit the measurements, but every single example of the concept in reality must have some sort of measurement. So the measurement is omitted, the measurement is open-ended, but it must have some measurement. So, however, there's no specific, and when you form the concept, there is no specific limit to the repeatability of the process. This abstract sequence, consequently, is unlimited, as it has no defined limit. Here is where we discover the concept of infinity, as infinity refers to something that is unlimited. Infinity is an attribute of a sequence that represents a limited process. It's an attribute of a sequence. Let me repeat that. Yeah, it's an attribute of a sequence that represents a limited process. Because when you think about that sequence, when you form the concept of that sequence, mathematically, in abstract terms, in the mathematical abstraction, there is no defined limit, and in that sense, we can say it's unlimited, and that's where the concept of infinity validly comes from. It basically names the fact that there is no specific limit to the process. The specific limits are omitted in the formation of the concept of the infinite sequence. However, in each concrete example contained by this universal, there must be some limit. And with this definition in mind, we can properly use the concept of infinity in mathematics while staying true to the legitimate metaphysical basis of the concept and avoiding applications of the concept that lead to commonly debated mathematical contradictions like Zeno's paradox. I'm going to get more into Zeno's paradox in a future video when I actually discuss this topic, as I've talked about at the beginning of this video. I'm going to get way more in depth with this and explain where Zeno's paradox goes wrong. Essentially what it's doing is it's conflating this abstract principle of infinity that I talked about with the concrete example. It's basically saying that it's basically misusing the concept. It's misusing the fact that there is no specific limit of the concept and applying that to the concrete example, which is wrong. Because as you see, when you form this concept of the infinite, of this universal, you're saying that essentially that in each concrete case there is some limit, but we omit that measurement when we form this concept. There must be some limit, but that limit can be any sort of limit. It can be anything. There's no limit to that limit, essentially. And that's where infinity comes from. That's where the concept of infinity comes from. And what Zeno's paradox essentially does is it conflates that abstract principle with the concrete example. It conflates the universal with the concrete. So yeah, that is essentially all that I have to say for this video. That was my essay. If you like that essay, look forward to the stuff that's coming in the future, because there is going to be a lot more like this coming in the future, because this is some fun stuff for me to talk about. I love this topic of Zeno's paradox, infinity, those sort of things. So yeah, thank you all for watching, and I hope to see you all in the next video. Peace.